Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 11, 2025, about 6 days ago. The standout is a practical system that reliably generates over-the-shoulder dialogue videos, keeping characters consistent, obeying the 180-degree rule, and extending conversations through looping, with perfect scores on over-the-shoulder and 180-degree metrics and strong eye contact. The paper is titled ShoulderShot, Generating Over-the-Shoulder Dialogue Videos, and as we will see later, the results are quite compelling. In short, the method blends dual-shot image generation, looping video templates, and lip sync to build long, coherent dialogues efficiently. Building on that, one post says the method tries to generate conversational over-the-shoulder videos, shares a funny example, and draws moderate engagement with about 99 likes and 13 replies. Alright, this opening figure lays out the 3 pillars of the setup. First, look across the full panel to see the over-the-shoulder pair, where the same 2 people swap foreground shoulder and main face while staying consistent. Next, the green check and red cross illustrate the 180-degree rule, keeping the camera on a single side of the axis. Finally, the film strip icon signals support for long, multi-turn dialogue sequences. Next, the authors show how the dual-shot layout enforces spatial consistency. Focus on the big left panel, where shot 1 keeps character A on the left foreground, and shot 2 mirrors it with character B, while the shoulder of the off-screen partner anchors the over-the-shoulder view. Then look to the compact right diagram, which is a top view that fixes both cameras on the same side of the interaction line, keeping the 180-degree rule intact across all cuts. Moving to this diagram, you can see the full pipeline from text to finished dialogue. First, a structured 2-panel prompt drives a LoRA-tuned flux image model to create a dual-shot reference. Then, each cropped shot becomes its own looping video using a LoRA-tuned 1 image-to-video model. Finally, the system lip-syncs to the provided audio and assembles alternating clips into multi-turn dialogue. Now, this schematic explains the looping diffusion. Start by looking over the full graphic, where frames are arranged on a circle so the start and end meet seamlessly. The left wheel shows one denoising step, with segments processed independently and blended in the overlapped stripes. Then, the right wheel illustrates the next step, where every segment shifts by a frame offset, breaking any fixed boundaries. Together, the overlap count and the frame offset remove seams, while enabling arbitrarily long loops. Now, this graphic walks through the training data filter. First, focus on the whole row of icons, which starts with raw dialogue videos. Moving right, the arrow marks scene and face detection that segments shots and tracks who is who. Then, the purple-framed triplet picks ABA loops and selects the B to A reverse pair. Finally, the last block applies filtering and ordering so shoulders land on the correct sides, yielding clean over-the-shoulder pairs for tuning. Now this table sums up the quantitative head-to-head. Look over the full grid to see 3 metrics: over-the-shoulder composition, the 180-degree rule, and eye contact. The key pattern is straightforward. Our approach hits 1.00 for both over-the-shoulder and the 180-degree rule, and reaches 0.60 for eye contact. By contrast, Mocha and Gemini trail far behind, while GPT-4o gets close on over-the-shoulder, but slips on the 180-degree rule. Building on that, this table compares 3 looping strategies using 2 quality metrics, with lower being better. First, focus on the whole grid to see the methods listed at left and scores at right. The reverse playback and the first-to-last frame control both score worse, around 3.1 to 3.4 on FIDV and near 370 on FVD. In contrast, loop denoising lands at 2.35 and 284, indicating smoother, more natural loops. Building on those results, 2 takeaways stand out. The dual-shot plus fixed camera geometry reliably enforces the 180-degree rule while keeping identities consistent, and the looping diffusion with overlap segments enables long, seamless dialogues. A quick note: LoRA means low-rank adaptation, a lightweight fine-tuning method. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.